Glad you find it useful. Hello, Reagan and Ater Lasita. So we're starting a little bit late today. It's a bit more relaxed, but let me just configure my stream. And then we can begin. So how have you been? How was your week? What kind of projects have you guys been working on these days?
Sword.
The sword.
The sword. The almighty sword.
Okay, so let's update the titles to Q&A&Critique. I'm gonna just bump the time to half an hour. Copy to the video. Update all. Okay, ready to stream. Oh, it's streaming already. Okay, let me just double check on Twitch, just in case you guys are there. And then we'll begin. I am online. Okay, so welcome everyone. Welcome to the Q&A 26. There has been a 2-week hiatus, but I'm now back. And we're back here to continue working on the short film for our client, Unknown DJ. And we have Slink, Reagan, Chili Dudes, Ater Lasita, and 21st Century here connected today. And the topics of today that we're going to explore is modeling that Slink has been working on over the past week with a sword that he has submitted here into the chat. So we're going to take a look at the sword and see how it compares to his first piece of art that he did to his current piece of art, which is looking mighty fine. So that's the first thing on the agenda. Then after that, we're going to take a look at, I'm going to practically start working on this mind map and maybe explore a couple of our tools with Erindale's ETK scattering system, which he has updated with a Raycast Scattering system and also some updates to a randomizer and foliage scattering. So this is a sci-fi project that I'm working on. Over the past couple of weeks, I've finished a mind map and we have a first test animation to do to try out the stylized painterly that we're working with. So are you guys ready? Yeah, feel free to open up. Yeah. Feel free to open up your mic, throw in questions. If you want to have your art looked at, we can throw it to the queue. I'll be here for the next hour, maybe an hour and a half as I stream this, and hopefully we can go through the exploration with Erindale's toolkit and geometry nodes and conceptualization with grease pencil also to get the idea done. So yeah, whenever you guys are ready, just open up your mic and we can begin. So Slink, shall we start with your art?
Yes.
Is it this one?
It's one of them,
it's
definitely.
All right. Here's the piece right here. So we have the sword with gold. You've got fur on the sword hilt.
Yes.
Very cool. You got a grunge on the metal. Got the blade coming on. A little bit of grunge on the lens, on the bloom. It's a one-piece hilt, like a forged sword. Nice.
Definitely.
So what's the inspiration of your sword?
Well, I found my first ever Blender project. It was a, we say, RuneScape sword.
Which is this one, right?
Yeah.
Your first project.
Yeah, really basic, just cubes, extended, a ball. Is there also basic materials and no HDRI lighting.
Yeah, nice. It reminds me of my first models as well.
Yeah. And I was like, I can do it better. And then I did.
Okay, so let's open up the mic. What do you guys think? 21st and Chili Dude, CK, Reagan. What's your first impression of Slink's sword? You can see it in the voice chat here in the Q&A and critique. Rolling up. First impressions, what could be improved?
I really like the glow and the reflection on the kind of the way he composed that first image.
Good. Yeah, I like the bloom as well with the grunge there, right here.
Also, there's lens flare, but it's really subtle, but it makes it even more real.
Wait, where?
There's like a little blue tint,
Here?
just a little bit. No, a bit over the hill, like there. It's a little blue there, bluish, and that's the lens flare. Very subtle.
Now you...
In the third picture, there's more lens flare in the background. That's the second. There you
Oh,
can
here I
see
see it. Yeah, yep.
very much flaring.
Yeah, it's more evident here. How are you doing the lens flare?
Well, I copied it from another dude on Gumroad. He made it for free and it's sick as fuck.
Oh, you'll have to link me that because I always want to use lens
Well, yes.
flares.
Wait, let me look. Let me find it.
And how did you do the hair on the curves?
I used the hair particle system.
Hair
A
particle
bit
system.
of grooming, a bit of curl, and wibbly wobbly, it's done.
That's a really nice touch.
Yeah. There's the lens flare.
Dirty lens.
Also.
Free. Can't believe it. That's so good.
Free.
Hello, Zach. How you doing?
Hello.
Doing well. Sorry, I was a bit late today. I got confused with daylight saving laws.
That's okay. I'm also late as well, but today is a very relaxed day, so you're technically still on time. I just started the stream about 5 minutes ago.
No. He's not late. We are too early.
Yeah, we're too early. All right, good. Well done, Slink. Like compared, for your first piece, compared to your first piece to your second revisit of the project, I think you've improved over 100 times.
Yeah.
The little details, the lens, the rendering is much nicer. I think the lens flares on your white background are a little bit too subtle. I can't see them on my screen, to be honest.
Yeah, it is really subtle, but if you see the render without it, then you notice it more.
Yeah, but that's a nice little touch for that kind of realism. Also, the grunge with the bloom and things, metal materials, kind of nice. The details on the hilt, well done. So, what do you plan to do with the sword?
I have no idea.
It looks like you're gonna have to make the whole suit of armor, I suppose.
Oh no!
No.
Human modeling. Ah.
All right. Okay. Okay, so let's move on and let's go do some exploring with conceptualization with geometry nodes and think. Thank you, Slink. I also said I combined it and said think. Sorry about that. Thank you, Slink, for the submission and the piece. So, next week we'll see what you do. Looking forward to it. Yeah, this week I have been quite busy with a lot of different projects. My first realistic mountain scene was created this week. It was a lot of fun. Let me just give you a sneak peek. 1 second as it loads. Here it is. Sneak peek of one of my latest pieces. That's quite a nice project. Testing out cycles, testing out scattering, geometry node scattering, things like that. So that's what we're going to look at today. So I'm going to just save the scene, and I probably should load up the latest dev build of Blender, which is 3.1, and I'm going to download the ETK pack from Erindale, which you can find in the comments.
Sick.
And he did.
Also, it costs $50.
Really, he upped his price, €15. But
Yes.
I highly recommend it.
100% worth it.
So the version 2 fields is the one you want to take a look at because that's the one I think would be most useful. So I have it downloaded to my library, generative modeling, and the version 1. So let me just make sure this loads correctly. Yep, good. So what we want is we go into the scripting layout or whatever and import the add-on because it is now an add-on. Add-ons, generative modeling, name, ETK, Erindale toolkit fields, number 2, install. There it is. Let me just make sure the version is bumped to 2.0. So we have Erindale, Joshua, and Ben. He worked on this, and basically it just gives us a whole bunch of extra tools. So for example, I create like this plane here, and I create a cube for testing purposes of the raycast, and I'm going to use an icosphere to scatter, which we can always do inside the geometry nodes. Let's take a look and see if he has the
Also,
raycast nodes.
If someone is asking, this is Cinema 4D.
Yes, I'm using Cinema 4D compatible with Blender. Alright, so to find his nodes in Erindale's toolkit, you have like this red at the add menu, and you have curves, fall off, you got things for fields, generators, which are pretty good, including a good friend of mine, Pers's node, which is great. You got mapping nodes, mask nodes, and utility nodes. So the one we're looking at is a utility node. There are 2 of them. One is foliage for scattering, which is quite good. And that's the one I've known the most. And the other one is random float or random vector, and also a shrink wrap possibly. I can't find the raycast. Where is it? Distance call, camera dial, selection, mapping. Let's see if there is a raycast. Raycast. We'll have to design it ourselves because I don't think it's uploaded yet. But basically what we want to do is typically when you scatter something, let me just show you. So we make a new tree and we create, for example, this foliage from node, add Erindale toolkit, utilities, one called foliage. When we add foliage, we can like choose a collection. So let me move this icosphere to the rig collection. Go back to my plane, select the rig collection, and it starts to scatter immediately. After that, I'm going to add in a join node, which is underneath geometry, join geometry. And then I'm gonna so I can see the ground, and then I will change the scale down here in the foliage node. So the way the foliage node works is it basically gets your emitter, which is a surface. So for example, if I start changing the surface a little bit and sculpting it, it's going to practically scatter on that dynamically to however I want. And the good thing about this ETK foliage is that we can control what's in the render and what is in the viewport. So we can kind of control the viewport responsiveness quite nicely. Then after that, with the foliage, we have the minimum distance, obviously, the seed, which is everything we need for scattering. Then we have a normal mask with an angle deviation. If we lower the angle of the angle deviation, right, or just change the normal masking. Right now we have a mask of okay, it's only pointing on Z, but if we turn on the mask with, as you can see, the mask is changing around the object to kind of give a scattering location of some kind. And then we also have a deviation, which means if we have too much, as you can see, it's scattering on the edges here. The angle deviation, the smaller it is, the smaller the angle, the less slope the things will scatter on. So this node alone I find extremely useful, super handy, just for that feature alone. So I'm going to be using this a lot. But the problem is, if I move the ground, and if I want to like move a group of bushes or a pile of rocks or like a connection or something, it's not going to work very well because it's based on the ground mesh. So what we need is we need something that's based on raycasting. So if we have, how does a raycast work? Have you guys watched the latest tutorial from Erindale about raycasting?
I did.
And what did you guys learn from that?
He did too.
Oh, you did too, Zach? Sorry, your microphone's quite quiet, Zach.
Yeah, he's on phone.
Oh, okay.
Yeah. So Raycast by itself is just a line in space which is shot in a specific direction from a point out or from a plane.
That's right. And we have a concept of a hit distance, hit normal, and hit position, and if something is hit. Which means if we take a look at the basics of a point scatter, so let's go into the instances menu, instances on points, and that's what we want. We can choose which points we want, and then we have an option of rotation, scale, instance, and the points. And then we have a transform or transform the geometry or points. We can also create points as well. So instances to points. Let's just see what the points, what other points ones we have. Points to vertices, or instances to points, or points on faces, instances on points, set point on radius, points on volume, mesh to points. Let's try mesh to points. Radius and position, cool. Let's take a look at this mesh to points. So as you can see, all the vertices are now points. If we take a look at the edges here and the face corners, or the points, here we have all the points of the instances on a point cloud. Maybe that's not what you want though. We go into the transform node. We've got face corners, edges, and vertices. So here are all the vertices. So what we need to do now is we need like a raycast of some kind. So to set that up, you need a couple of nodes to work from first. So one is the angle and the location from a plane, for example. So to do that, what would you guys need to do? Did you guys watch the tutorial?
Yes.
Okay, so what did Erin say? What do you need to do?
You need to raycast it from the plane to the ground.
So that means we need to get the object to the ground, right?
Yeah.
That's the direction.
You can drag. Wait, Trace. You can drag from the outliner to geometry node and it will import it as a. Yeah.
Perfect.
That's cool as fuck.
That's the way it should be. Right, so now we have this geometry and we have the location, right? So now what do we need to do? We need to subtract the vector from where we want to point, right? Is that what we need to do?
Well, first you need to know the distance.
The distance?
Ray.
Here we have ray length is 100 meters. That's good enough for now.
Yes. Hopefully.
So
then
I'm going to drag in the world space as well. That's going to be my direction. Or I tell you what, let's make this actual object, the plane, the direction. So you get the location subtracted onto the other location, and this will give me the ray direction to some degree. And once it is at the hit position, it should give me the translation of the points, which is not going to work here, sorry, because that's not a field. This is the round one is a single value. The diamond shape is a list, I guess you could say. So now what? What comes next, Link? The target geometry.
Then you know the distance. Then you need to know when the ray collides with the ground mesh.
The source position. Oh, you could just do this. Ah, you don't need to do the direction, right?
Ah, man.
I used to do this inside the first version of geometry nodes, which is really easy, but now I'm using the fields version and now I'm like completely lost.
Yeah, kind of same. But it's worth it. It gives more freedom.
That's right. So I want an instance on points. The points are is hit, is on the boolean, is on the selection. I guess it's on is hit.
I think so.
And it's not working.
Well, you need to join the original mesh firstly. So.
And the instance is the icosphere, right?
Yeah, there's currently no instance object.
There you go.
Bam! It works.
Let's just change the scale a little bit.
You just Raycast scattered.
Thanks.
Hey.
Let's just test it.
Great.
Let's test it. But it's a bool, okay? So it's like one ray hits it, and then it's not set up inside the bounding box.
Definitely.
So this is where we need to think about what would Erindale do.
What would Aaron do?
So we have a bool.
Yeah.
And we have the concept it can detect if it's hit or not. That's basically it. Is it hit? Yes or no. And then we have a hit position as well.
Wait a minute. Maybe it's because the plane doesn't have enough subdivisions.
Alright, let's add some. Go into the mesh.
As far as I know, it's a one ray per phase or per vertice.
Okay, so add a few
Either
more.
of those. Maybe now it works? Nope. Fuck.
It's just if a ray is hit. Based on float, integer, color, boolean, interpolated or nearest, hit distance, hit normal. Let's just see. Okay, so we got instances. Is hit true? It's just a true or false.
Yeah, it's a boolean.
Hit position is a vector.
Hit normal is normal, I believe.
Yeah, like the angle that is hit. So this would become in handy quite later. The distance is how far it's high. So here we have a single float. So question, you have a diamond with a dot in the middle, and you have a solid diamond. What's the difference?
Yes. I don't know.
Damn.
Well, I'm as lost as you are.
Well, it looks like it's something I shouldn't be doing live. So let's go back to the creative aspect of the work.
Yeah.
But okay, so that's one concept that I need to develop. So let me just save the scene for now. Actually, no, I won't save it. And let's open up my other version, which has the project, which is more stable. So I need two things, right? So when you're creating with geometry nodes for modeling or procedure modeling, you want things like, go to my study, make a new folder. So we have, you guys can see the screen, we have Raycast Scattering, all right? So we have two, which is foliage scattering, which is what I showed earlier, which we have with the ETK, which is kind of like a scatter on an emitter. It's basically just scatter on an emitter. You have weight maps, you have randomization, you have slope, you have all of these concepts. You also have distance, minimum distance between different things like that. And you have this all packed together neatly with Erindale's project. Then after that, the next concept is we have Raycast Scattering. So Raycast Scattering is based on a bounding box. So if we take a look at my notes, I do this in Unreal Engine quite a lot. So I'm trying to replicate it from Unreal Engine into the actual project. So let me just show you the idea of the project. Right. That's a video with the video. Here it is. So basically what we want to do is we want to create a bounding box that shoots rays from the top, and when it hits something, along with collisions, it scatters everything in that space. This is extremely useful for like a pile of rocks, for example. Here is a picture of the rocks that I created in the world. Basically, here's the pile of rocks with a seed, and it's inside the bounding box, and I'm pushing it into the world without needing to define. And also, like, I can help. As you can see, the red lines are the rays that are shooting up into the ground. So that's what I need to recreate inside Geometry Nodes, but unfortunately I don't have an answer for you right now. Sorry for being anticlimactic. So the next thing we need is randomization. Here is a picture of basically what rays are doing. So it shoots from the top, and when it hits something, it gives out a signal. And this signal is it hit? Is that the normal? Is that the position of the ray? And once I get that, then I can decide how the rays are set up.
You can imagine rays as an infinite thin cylinder, which has like data about everything it hits or isn't hitting.
And in fact, here's the concept inside Unreal Engine. It's a bit blurry, but basically I get the bounding box, and I use the bounding box to spawn the instances. So I spawn the instances as a mesh inside of a concept which is spawning onto the grid. So I use like a grid raycast, which analyzes the rays, and then I take that data from the rays, the position data and the rotation data normals, and I use that as the position information or the translation information of each spawned instance. So it's basically use the bounding box, raycast, and then spawn at the position of the raycast. How to do that in Geometry Nodes is still a work in progress, but hopefully next week I'll give you some answers. So next thing after that,
Aaron.
Aaron, yeah, Aaron might give us some answers. He actually made he talked about it in the threads. Actually, he showed us something. Zach says the raycast is looking good, and Rego had to go, but that's okay. And 21st is still tuned in, so thanks for hanging out. So now we have Raycast Scattering, and now we want random object per seed. So random object per seed is a really cool concept that I also want to show you, which I'm going to recreate a little bit here. Is basically, let's go to last month, and let's open this up. So basically, you have a set of pre-made objects, and using a seed or the position of the object, you can select or define different variations of that particular object. This is extremely useful for layout and for like conceptualizing what you want to do. So this we can do with Geometry Nodes today, I think. I'm going to use the old legacy Geometry Nodes for now, maybe. Instance index, instance on points. What do we have? Let's just explore a little bit of what nodes we have. Let's see if I can do it in fields. Attribute statistics, capture, transfer, color ramp. Let me just full screen it and get the list nice and big. You guys can see. So we've got color. We don't need color for now. Attributes, this may come in handy. Curves may come in handy for like spawning things. If we take a look, for example, here with this project, same with Unreal Engine, you can like spawn random objects onto a curve spline and use that for creating like bricks and stuff. Super handy. Where's another example of that I have? Here. Okay, these are just randomized seeds, okay? So as you can see this, I have like placement of objects, you change the seed and it changes the layout of those bricks. Nice and simple. Here with this object, here it is. So here I have a curve and it's randomizing the selection of the bricks on that curve. and I can use that to add the raw instances as well, and that changes the length as well. So these are like layout tools that I need to help me conceptualize inside Blender. So Blender is a little bit harder than Unreal Engine when it comes to construction blueprints, but everything is possible. So we have subdivide the curve, we have the curve sample of the curves, or so these curves could come in handy for that type of concept, especially curve parameter of the factor, curve tilt would be handy. Endpoint selection could be handy as well. The spline length, super important if we want to like get the length of how many instances we want and what distance. The spline resolution might also come in handy later, and the curve radius for like the size and stuff like that could be handy as well. So all of these would be handy for another day. This, but not for today. Then we have curve primitives, we got geometry. So here we have the bounding box, which is what we need for the raycasting. We got the raycast node for the raycasting, but it's not obvious how it works so far. We've got setting the position of the actual points, which is going to be important. For example, the hit position of a grid, you could plug it into the here, and maybe that would work. And then we have transforming, and we got all the input data as well, including position data and radius. Then we have the instances, 1 points, 2 points, realize instances, rotate. And then we need meshes, mesh to boolean, subdivide, primitives, output, points, more points, distribute points on faces. Text and textures are not necessary. Utility align Euler to vector is really useful because I just found out about that you could do billboards with this. But what we need is a switch. Okay, so I'm going to delete everything that I won't need for now, and I'm just going to create a switch. So if I have one object, which is this icosphere, well, let's actually use some geometry. So I'll close the curves, attributes, geometry, and put mesh primitives. If I have a cube and I have an icosphere. If I have this cube and this icosphere, basically I have an option of creating a switch to swap one and the other, right? So that's the basic concept of layout. So if I have a true and a false and my group output, I can make a choice inside of my stack to choose which object I want. So basically I use the switch into the switch node, I expose it to the group input, and I have my two objects, cube and icosphere. And then I output it into the geometry over here. Clean that up. I don't need this one. There we go. If I go back out and I go into the modifier stack, I have a bool and I turn it to 1. Now I have an icosphere, a parametric icosphere, and if I turn it to 0, I have a cube. So that's the first thing I want. I can store two different meshes. So I can make a chair and I can make a sofa. Which one do I want, the chair or the sofa? Great. But what happens if we have both? But it's a bool, it's only one or the other. But you can like duplicate this and change the value. So every parameter you expose is kind of like an override. So that's one thing you got to keep in mind. If you want something to work between multiple pieces, so for example here we have a resolution of subdivision 1 or 2, and here we have vertices 1 or 2. If you want to keep values common between both or all geometry trees, so for example here we have 1, 2, 3 pieces, right? To make it common, you would add something like a value node, or in this case we need an integer. You want to make you put an integer somewhere, for example here with the number 2, and you press Ctrl G and you make it into a group and you move out. So now I'm going to call this a GN value or integer. This is a common integer value that I'm going to place everywhere. And inside the common integer value, that's going to be an override inside of all the meshes. Let's go into wireframe mode just to see. If I change this, all of the geometry node trees are going to change simultaneously, right? So if you want like a value on all of your scattering, then you would make it, you'll put your integers or whatever you need inside an actual node group inside the node tree before you're exposed to the top surface level, because these are overrides, as you can see. So if you separate that logic between the geometry nodes, it's going to be nice and easy to help you understand, okay, so I want one to be individual parameters and I want things to be global parameters. The same thing happens with shaders. You can do the same with shaders. So you can have your custom attributes per object. So let's just show you how we can do this with materials. So let's go to materials. Let's create a new one. And in this material, I want a color called, first things first, we're going to get object info. In the object info node, we have a couple of overrides already. One is location, color, material index, and random. The one we want is color. So if I have, for example, a mix RGB, oops, not Mandelbrot, mix RGB, and I plug in a mix factor with an original color. So let's make another RGB node. And this color here is basically red. And this red color is going to be affected. Oh, let's make it light red, like, you know, coolish pink. There you go. A bit more cool. There you go. So I want this color to be fixed with the color of the object and then thrown onto, mixed together into the material. So if I take a look at the material here, nothing is happening, because if I, oh, it is happening.
You need a set material node in geometry nodes, because if you generate a mesh in geometry node, it doesn't have a material. You need to set the material first.
Well, that's kind of a annoying workaround.
Well, yes, but if you have like multiple objects in one geonode setup, it is helpful.
Makes sense, yeah. Okay, so it's all set now. Compiling. Still compiling. There we go, compiled. Go back to shading. So here we go. So now we have the pink. But if we want to change the color of this particular object, so this is global. We have one material for all the objects in the geometry nodes. But now what happens if we want to customize this color? So inside the object parameter, which is a container, as you can see in Blender, we have a mesh data modifier stack, which contains the geometry nodes. Inside the mesh data, we have the material, and then we have an object container inside of a view container. So the object container could be anything. It could be something separate than a plane, or it could be something completely different. And inside of that, we have viewport display color. So the object color can be anything we want. So I just created, by exposing the color inside the material, an override. So now I can use this as an override. And on top of that, if I want to, I can also use vertex colors. I'm not sure if the geometry nodes is going to work, but we'll see. But you can also use vertex colors to paint whatever you want. So for example, I'm going to use the color bright blue, and I'm going to, in vertex paint mode? Yes. I'm just going to paint, no, it's geometry nodes. I can't paint it. Oh well.
Yeah, it is procedure generated geometry. No painting.
Unfortunately. So I would probably have to apply that. But in other objects, for example, you can customize your vertex colors to whatever painting you want, and it would work however you want it to work. And you can also grab your geometry nodes parameters, and that could also help as well. So after that, so now we have material overrides inside of a single material. If we have multiple materials, so for example, if this particular guy, or I make a new object, sorry, let's make a torus. So if this new object has a separate material, let's go into shading, add him a new material, and I want his color to be the same as this guy, what I could do is I can, just the same as geometry nodes, turn this into a group and rename it. Shader node group. I'll call this an RGB value. So this node group now is, I can use it, this node tree as well. And let me just grab it, SG, put it in here, so that if I change this, it will change over all of the materials, not just that one material. So this is how you connect materials together with an override by using the object color. So that's kind of these are things like, if you understand your node groups and how to work your values and put them into groups, I think this is a great tip that someone gave me the other day. And I just wanted to share that with you because we're going to need it for conceptualizing and randomizing objects. Now, if you go search into the server, we're going to go back to our list. We've got random objects per seed. So we have random materials, which could be based on a common values, override values, vertex colors, if not procedural. Yeah. We also have override values from the object color, exposed parameters, fields, I guess you could say. And then we have common values, values in node groups between assets. So those are the three things that we have. So now we need to think about random objects. So we have the concept of a switch, which is only a bool, which is kind of like a true or false. Basically, choose between two and no more. But we need more variations from that, and we need them in like a bunch of different piles and different things like that. So we're going to need a different system. And to do that, we're going to need instancing of a collection onto a vertex using an index. And we can drive the index based on whatever we want. So let's go back to our node tree. Switch over to geometry nodes. Here we go. So we have true or false, integer. So let's go create a new scene just to give a clear space. Make a couple of objects like a sphere, a torus, and a triangle. And okay, so we're all good. This is going to be in my collection. So let's just move this to a new collection. We'll call this the instances collection. And these are going to be placed inside of a particular object, which I'm going to use as a mesh, just a single vertex. Add a single vertex, good. So this vertex is going to be called my GN placement, random placement. And the single vertex is going to have a node tree, or geometry nodes, and we'll just take a look at it in the nodes groups and open it up, unhide this one, unpin it, and open this one up. And here we go. So let's begin. Slink, or anyone here, do you guys have an idea of how we should begin this?
Nope.
Nope. No idea. And also thanks, J-Bar.
Nope.
Thanks for the comment. I hope it's useful. All right, so what we want to do is we want to use an instance on points. We have a single point, right? So instance on points. We've seen this node before earlier. I'm going to full screen it. And on the instance on points, I'm going to get at the collection. So input, collection info, select the collection that we were looking at, which is called the instances. Whoops, not instances, instan.
Nom, nom, nom.
Nom nom. Wait. Oh, I didn't make the collection yet. New collection, instances. Okay. Now I have a collection. Go back to my placement. Now I can select the instances. Boom. So now I have, go back to full screen. I have separate children. And I want the geometry into instances. And I want to pick instance. And then I want an index. So now I'm going to get an integer. So basically what I'm doing is I'm getting the collection info as separate children. So not the whole collection, just all the contents of the collection in the original position. I'm telling the instance on points to say, hey, pick an instance, pick one, not the whole collection. And I'm going to have an index. And the index is going to start from 0 to 1 to 2 because there are 3 objects. So 0 to 2 was for 3 because 0 is counted like 1. Computer programming stuff. And let's zoom out and move over here and see what's going on. So hit 1, it goes to the sphere. Hit 2, it goes to the torus. Hit 3, it goes to the triangle, and it repeats. It repeats itself, which is kind of nice. But everything's in a bad offset. So what we're going to do is we're going to click on relative. So now the position is changing relative to the world space. We're going to click on original, and we're just going to snap these to the center of the world. And then when we change the seed, the instance index is changing the object. How cool is that? It's kind of handy, no? So that's one thing we can start.
Really cool indeed.
So what happens if we want to select something random, right? Notice that this is a cycle, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's not very random. So
isn't there a random node?
That's right. We're going to use a random value. Choose it, change it to integer. Minimum to maximum, which is change it to 3. 0 to 3, or 0 to 2 in this case. Move it into the instance index. And now we have a seed. This seed could be anything. So now if we change the seed, it's going to pick something random every single time, or nearly every single time, just picking a random value of those 3. So this is how we pick a random item. Great. So let's change it a bit further, yeah? So we're going to get the position node. And I'm going to just change the position, and then we're going to position into the seed. And now when I move, which is the try to get? I think I have to get the object of self. Why doesn't it just? Okay. Technically, so what I'm planning to do is I want the random seed to change every time I move the object. Basically kind of like a driver driving the seed. But to do that, I need to grab the object position, or get the object position, which is where? Should be with the position field. And then with the position field, which is the socket based on the point, you should drive the seed. Let's separate XYZ and see what happens. What values have we got? Doesn't say anything. Change the seed. Nope. Value.
I think either you need a color ramp or a map range node. I think map range node would be better, so you can put like higher values as the output.
But I only need to get the position data. That's all I need.
I think position is not world space position. Position is the vertex position.
So how do we get world space position? We'll have to get itself. We'll get itself. Get its location.
Location in world space.
Relative.
Then if
tell you what, let's get a string, because
why did you just moved it on the y-axis, but you have like separate XYZ.
Yeah, you're right.
The X Still no.
Okay, so the best way to do that is using a string. String. How do you curve to string or string to curve? String to curves. And I'm going to use a join node. So geometry, join, use a string. The reason being is that now I can read things. So now I can, like, the string could be the location. Or, okay, what other things for string? Let's go take a look inside the mesh printer's output text. Join strings, replace strings, slice strings, special character string, length string, value to string. Now we have a value to string, and we can attach any value that we want. So let's attach the X value just to read it. There it is. And move the X. It's doing nothing. It's doing nothing. Move it to original. Doing nothing. 3, 2, 1.
It did something.
It did something. So let's move the decimals up 2 points. There we
Hello,
go.
Ben.
That's what we need. So I guess I need a truncate. Truncate or math. And we'll use the math truncate function. Truncate is kind of like round into decibels. So now it should change the seed. There we go. Now it's changing the seed based on its position. Boom, 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 boom. So there we go. That's what we wanted. And also I'm going to just transform the text just a little bit so you can see it. There it is. And so visualizing what you need, the string to curves node is super useful. Basically because I need things in the viewport to see what I need. So that's the best workaround. Until geometry nodes has 3D widgets with everything, it's going to be what I need. You can basically use this as kind of like a viewer, I suppose. I just unhide that, value to string, move that in, and then I can just connect that whenever I want. So this truncating, now it's like truncating, as you can see, is no longer a float, but now an integer, just like the index of the randomization. If I move this into truncate here, it's changing the number positive, negative based on the location, which is good. And if we want to make it change faster, we can use another math node. For example, multiply by 4, so that it's a little bit more sensitive, with the placement of the random object. So now we have a random object selector. Wonderful. And that's kind of cool. That's kind of handy. That's exactly what I needed to kind of like create. So for example, I just duplicate this, move it around. What? Why has it stopped working? Duplicate. Huh. Oh, that's because it's a different, the same object. Okay, so let's try this position and let's see what it gives us. Gives us nothing. Truncate. Gives us nothing. Separate into X. Position into X. It's as you can see, it's a dotted line, meaning it's a list of positions, so it's not the actual object position. How do we get transform?
Are you looking for the object's position?
The self position, get self position.
Yeah, I'm not sure if that's possible yet.
What?
Yeah. Like, you're meaning like the object's position, not the mesh position.
Yeah, I want the object position.
Yep, that is currently not possible unless you use like another object that you're referencing that's at 0, 0, 0. It's one of the things that really should be in there, but is not.
Damn.
Yeah. For some reason, and I think this will be coming in 3.1 if people bring it up, but I haven't seen people bring it up yet. It's just that everything's in the local position space and not the global position space.
There's
which
no
is-
difference, yeah.
Yeah.
Point position. And the point position is just local point position based on a list.
Yeah. There is a workaround for it if you just have an empty at 0, 0, 0. Then use the object position for that using
World space empty.
yeah, and then you have on relative instead of original, and then it'll yeah.
Yeah, gotcha. Cause alright, so world space, you know, relative to world space null. Yeah, I always have a world space
Yeah.
null in my scene, so that works out as well. Okay, fine.
There is an object info node should be there should be a position and then a global position input, but currently we only have the local position input, which is kind of annoying.
Alright, so it's a matter of time, I suppose.
Yeah. A lot of stuff is going into 3.1, a lot of quality of life changes,
Yay.
but I'm getting kind of annoyed about the waiting. Because it's like, yay, we finally got the fields working. And then it's like, oh, you have to wait 3 more months until you get all the,
Old stuff.
you know, comfortable, yeah, the quality of life changes.
Yeah, user experience, improve that. Also, the
Yeah.
switch, apparently the switch is only for geometry. It's not for values. We don't have a value switch, a field switch. Oh, wait, here.
Yeah, no.
Yes, we do.
no-
Yes, we do. Yes, we do. Yes, we
Is
do.
there?
Texture, collection, geometry. Yeah, perfect.
I don't think it's for fields, though.
No, it's just for, I mean, a field is kind of like a list, right? But like these lines that are solid, the triangles are technically fields, no? Just data. Well, how would you define a field?
A field. A field is like a vector for every single vertice, while a regular value is just for the whole object. One's for the whole object, one is for every single vertice.
Okay,
in
so
that
one's a
object.
list and one is a direct data value. Gotcha.
Yeah.
Basically, these dotted lines is the list.
Yeah. Which I'm not sure why they didn't like call them lists or calling them fields. Not entirely sure why about that. But yeah, they do the same thing.
Okay. So I made a switch. And now I can tell it to be a particular seed. Ooh, why is this seed?
The switch should be, what version are you using?
3.1.
Oh, 3.1. Huh. There should be just a checkbox for every like Boolean input, like 0 or 1.
Did it come out this week? Because I'm a week behind.
I'm pretty sure it's been around for a while. I'll check it real quick. Let's see. Switch node. In there. Oh no, it's not in there yet. I'm surprised.
Yeah, me too. Kind of annoying having this like slider instead of a tick box.
Yeah, and I know that this was weeks ago, but they were planning on putting in that one, and I was excited because it would make things a lot easier. But apparently they just didn't put it in yet.
Bizarre.
That was supposed to be for 3.0, not even 3.1.
Yeah, that's what I'm thinking now. Alright, cool. So now I have a switch to say random seed based on a slider. Or change the switch and now it's based on position. basically, I wonder if I can just jump this. Yeah, it works fine now. If I have a random seed, turn that off. So the seed is based on the actual direct feed to a seed based on the switch node, which you can change to whatever value you want. And you can now do, or change the switch, turn the switch on, and now it is based on world position, or relative world position. As you can see, the world space is a null relative to world space. It's kind of nice. All right. Not a lot of work done today, but it was good fun. So Ben, it's kind of cool that you dropped by. I didn't notice at first.
Yeah, I saw you were doing geonodes and I decided to hop by.
All right. Well, I guess I'll tie up this recording for today. I'm happy to be back, and we'll just close it off, and I'll just continue working here till it's lunchtime. So thanks for joining. I'll see you guys next week on Thursday at 1700 UTC. Same time, same place. And don't go, those who are still here. But I'll talk to you guys later.